Through the progressive achievements of science and engineering, man's machines have traversed immense distances to the moon, Mars, and Venus. He has flown vehicles into space and remained there for periods up to 14 days. But this is not enough, for he must learn more about the Earth, the solar system, and the seemingly endless regions of the universe. In the years ahead, explorers will walk on the moon and navigate the oceans of space, equipped with new knowledge to guide them. The year 1965 was but one chapter in the story of spaceflight and the exploration of the solar system. It was a year when man pursued his quest of space. The programs of the National Aeronautics and Space Administration require the combined efforts of several major centers. One of these, the John F. Kennedy Space Center, has the facilities and skilled teams to check out and launch the vehicles which place satellites and spacecraft in orbit, or dispatch them to far-off planets. The headquarters building is the hub of these activities. Here, Kennedy Space Center Director Dr. Kurt Davis and the administrative and management staff direct launch operations. During 1965, unmanned launch operations at the Kennedy Space Center advanced space exploration by flying satellites and other spacecraft to study astronomy and meteorology and conduct communications, navigation, and lunar missions. The vehicles and spacecraft they carry are developed by other NASA centers. The OSO and IMP satellites of Goddard Space Flight Center provide geophysical and astronomical information to scientists on Earth. OSO-2, a large orbiting solar observatory, was designed as a space platform for direct observations of the sun. 8 experiments were carried by the satellite to study X-rays, gamma rays, and ultraviolet radiation. This 545-pound satellite received its final preparation in a Space Center clean room before launching February 3rd. OSO-2 was designed to advance understanding of the sun's structure and behavior and determine the physical processes by which the sun influences the Earth. IMP, the interplanetary monitoring platform, differs from OSO in both design and function. The IMP-3, designed, built, and tested by Goddard, provides a new view of how the Earth's magnetic field extends into space, advancing studies of those regions near our planet. This compact, 130-pound satellite began its active life May 29th. In 1960, the world was thrilled by the sight of the Echo satellite as it crossed the heavens. In 1962, Europe and America marveled at live television pictures transmitted across the ocean via Telstar. Then came Relay and SYNCOM, more advanced communication satellites. The knowledge gained from these research vehicles led to the orbiting April 6th of Early Bird, the world's first commercial satellite. Owned by the Communications Satellite Corporation, Early Bird can transmit 240 two-way voice channels. These are used for telephone, high-speed data, or telegraph and television. This 85-pound relay station, with its outer shell of 6,000 solar cells providing transmitter power, is similar to NASA's SYNCOM. Launched for ComSat by NASA, Early Bird was placed in a synchronous orbit, appearing stationary over the mid-Atlantic. Space research has provided numerous benefits to mankind. One of the most important is improved weather forecasting. Global weather patterns are being photographed daily by TIROS 9 and TIROS 10 weather satellites. TIROS carries 2 TV cameras which take pictures of cloud formations once every 60 seconds, or more than 400 pictures daily. By mid-1965, more than 500,000 pictures had been received from the satellites, 90% of them usable for weather analysis. The pictures can be stored on 2 tape recorders or sent directly to a receiving station when the satellite is within range. TIROS 9 was launched January 22nd, and TIROS 10, financed by the United States Weather Bureau, was placed in orbit July 1st. Delta vehicles have launched all TIROS satellites, as well as most of the other unmanned missions. 3 centuries ago, Galileo studied the moon. Since then, astronomers have viewed the lunar surface with gigantic telescopes, but never with such clarity as provided by Ranger. Each Ranger spacecraft built by the Jet Propulsion Laboratory carried 6 television cameras with a combined capability of taking 300 pictures per minute. 2 cameras provided pictures of large areas of the moon, while the other 4 show detail. Ranger 8 transmitted 7,000 photos of the moon before crashing 15 miles from the pre-selected target February 20th. A month later, March 21st, final tests were completed on Ranger 9 and its Atlas-Centaur launch vehicle. It was sent hurtling toward the lunar surface, returning more excellent pictures from which scientists will obtain vital information for the Apollo manned lunar landing mission. Before astronauts begin their lunar journey, Surveyor spacecraft will precede them. It will land gently on the moon in mid-1966, make studies of the lunar surface, and send this information back to Earth for use in the manned mission. As a prelude to that flight, a dress rehearsal was conducted August 11th. Engineers placed a Surveyor model atop the Atlas-Centaur launch vehicle and sent it on a flight toward an imaginary moon. Centaur was developed by Lewis Research Center, and Jet Propulsion Lab builds the Surveyor. This successful test helped pave the way to a future soft landing by the operational Surveyor. To place heavy payloads in Earth orbit, put men on the moon, and send spacecraft into deep space requires launch vehicles of great size. For these missions, 3 series of Saturn vehicles were developed by Marshall Space Flight Center: Saturn I, Saturn IB, and Saturn V. During 1965, the last 3 launches in the Saturn I program completed the series of 10 consecutive successful flights, demonstrating the feasibility of using clustered rocket engines. 8 engines on the first stage developed thrust of 1.5 million pounds. Saturn I's second stage used 6 engines, which burned liquid hydrogen as fuel. For the Saturn family, Kennedy Space Center engineers constructed large launch facilities and developed techniques for performing pre-flight checkout. They also established storage, handling, and tanking procedures for using large quantities of super cold cryogenic fuels, as low as minus 423 degrees Fahrenheit. During the year, the last 3 Saturn I vehicles were launched at the Space Center. Each placed a Pegasus meteoroid satellite in orbit to gather information on the frequency of meteoroids which might be encountered in the near-Earth environment. The 3,300-pound Pegasus exposes large panels, 14 feet wide and 96 feet long. As particles collide with the surface of the panels, the impacts are registered and reported back to ground stations. The final Pegasus rode into space July 30th, compactly encased in the spacecraft section of SA-10. With a flame tail 300 feet long, the 190-foot-tall Saturn inserted the Pegasus into orbit. There, like a bird in flight, the wing-like panels were deployed. The second series of the Saturn family is the 1B, capable of placing a 17-ton payload into low Earth orbit. The booster stage for the first of these new launch vehicles arrived at the Kennedy Space Center August 14th. Its arrival marked the first time the Port Canaveral lock was used to transfer space cargo from the Atlantic Ocean to the Banana River. Previously, large Saturn barges used a slower route up the Intracoastal Waterway. Upon arrival at the Space Center dock, the first stage was offloaded and taken to Complex 34, where it was erected on the launch stand. Although essentially the same as Saturn I, design improvements reduced the weight of the Saturn 1B booster and added 100,000 pounds of thrust. The second stage is also an improved version of its predecessor. This model, burning liquid hydrogen fuel, has one engine, supplying twice the thrust of 6 engines previously used on the Saturn I second stage. Complex 34 was modified to accommodate Saturn 1B. Work platforms were constructed which completely enclosed the rocket during pre-flight checkout. An ingress-egress elevator was added. An automatic checkout center was built under the pad. And new equipment was installed in the Launch Control Center. Since Saturn 1B will also be launched from Complex 37, modifications there are already underway. Saturn 1B will give the United States the capability for 3-man space flights in Earth-orbiting missions of the Apollo spacecraft. The first Apollo spacecraft arrived October 25th, and a variety of tests were begun in preparation for an early 1966 flight. The engine section of the Apollo, or service module, underwent static test firings to verify the propulsion system. The command module, or crew compartment, underwent inspection and checkout at the Manned Spacecraft Operations Building. During these tests, the spacecraft will be placed inside an altitude chamber, where it is subjected to simulated altitudes up to 250,000 feet. These 200-ton stainless steel structures are the largest man-rated chambers in the world. To test the complicated systems of the Apollo spacecraft, a high-speed computer system was installed in the same building. The facility is called an A station, meaning acceptance checkout equipment for Apollo spacecraft. Signals are sent from the test area or launch pad to one of 5 such A stations, where the information is processed for immediate evaluation. By year's end, the Saturn 1B and Apollo spacecraft entered the final phases of checkout in preparation for its maiden flight in 1966. Our nation has accepted the challenge of landing men on the moon and returning them safely to Earth. The giant Saturn V rocket is under development for that purpose. The acceptance of that challenge is evident at the Kennedy Space Center, where Launch Complex 39, the world's first operational spaceport, has been constructed. For Project Apollo, the manned lunar landing mission, a mobile launch concept was chosen. To accomplish this, the Apollo Saturn V will be assembled and prepared for flight in the controlled environment of a building, not on the launch pad. The vehicle assembly building, largest structure in the world in terms of volume, was built for that purpose. Inside the 52-story building, an Apollo Saturn V can be assembled in launch position in one of 4 high bays. Platforms surround the vehicle for servicing. Second and third stages will be serviced in the low bay area. The Launch Control Center, occupied in 1965, is the nerve center of the complex. Here, every phase of assembly, checkout, and launch will be monitored. Each of 4 firing rooms has a picture window view of the launch pads more than 3 miles away. The Apollo Saturn V will be erected on a 445-foot tall mobile launcher. 3 have been built. The base serves as a pedestal from which the rocket will lift off, while the tower provides electrical, pneumatic, and fueling connections to service the Saturn prior to launch. The mobile launcher and rocket will be carried to the pad by the crawler transporter. 2 of the giant machines have been assembled. Each weighs 6 million pounds and is driven under a mobile launcher, lifts it, and transports the tower and rocket over a specially constructed roadway. The crawler will also move the mobile service structure to the launch pad. This tower was constructed at a parking site midway between the VAB and the launch sites. Work platforms situated at appropriate levels provide access to the rocket and spacecraft for final servicing. There are 2 launch areas at Complex 39, Pad A and Pad B. These pads, located near the ocean, are 3,000 feet in diameter. In the center is a hard stand 48 feet above sea level, with a flame trench dividing it. Under the sloping shoulders are control systems, electrical rooms, and high-pressure gas storage areas. From here, Americans will begin their journey to the moon. But before that historic day, astronauts must train and learn more about the space environment. They must maneuver their spacecraft in orbit and determine the effects of prolonged flights upon the pilots. This is the goal of Project Gemini, America's 2-man space flights. Gemini spacecraft arrive at the Kennedy Space Center about 2 months before launch. The spacecraft is taken to the pyrotechnic installation building for a thorough inspection. This is the first in a long series of pre-flight preparations conducted by the Kennedy Space Center and contractor personnel. One step in preparing the spacecraft for flight is the mating, or joining together of the spacecraft sections. This is the rendezvous and recovery section, which contains the spacecraft's parachutes. Another preparation carried on in this building are the tests to determine the weight and balance of the spacecraft seats. The astronauts who will fly the spacecraft participate in these tests. The parachutes for the astronauts and the spacecraft are packed in this building. Inside, the Space Center maintains the most stringent parachute control and inspection procedures ever undertaken. The Fluid Test Complex is a series of buildings used to check out the spacecraft with tests that are explosive and toxic in nature. Test firing of the spacecraft's small rockets, or thrusters, are conducted here. The spacecraft's radio and radar equipment are tested at this facility, called the Timber Tower. The astronauts use this facility to practice rendezvous and docking procedures with their spacecraft and the target vehicle, an Agena rocket. The astronauts also practice their spaceflight maneuvers at the Mission Control Center. In this Gemini simulator, The astronauts go through every step of their space flight, practice every maneuver, every movement, until operating the spacecraft becomes second nature to them. The two stages of the Gemini launch vehicle, a Titan II rocket, also arrive at the Kennedy Space Center by air transport. The two vehicle stages are erected at Complex 19 under the direction of the Air Force launch team. About 2 weeks later, the Gemini spacecraft is brought to the pad, hoisted to the White Room atop the erector, tested, and then mated with the launch vehicle. Near the end of the normal 7 weeks of pre-launch preparations, a simulated flight is conducted. This is a practice countdown in which every step of the countdown is performed except engine ignition. With the completion of the simulated flight, preparations are begun for the actual launch countdown. Each of the 5 manned flights of Gemini in 1965 toppled space age records. These records include Gemini 3, astronauts Grissom and Young, America's first 2-man spaceflight. Gemini 4, McDivitt and White, the first American to walk in space.
I'm gonna back down now. I'm under my own control.
Gemini 5, Cooper and Conrad, a long-duration flight, a world record, almost 8 days in space. Gemini 7, astronauts Borman and Lovell, topped this record with a 14-day flight. While Gemini 7 was in orbit, an amazing feat took place at Cape Kennedy. The Gemini 6 booster and spacecraft were moved onto Complex 19 and erected within a day after the Gemini 7 liftoff. Launch crews worked around the clock to prepare Gemini 6 for flight. The mission plan called for Gemini 6 to be launched within the 14-day flight period of Gemini 7, rendezvous with Gemini 7, and the 2 spacecraft would then fly in formation through space. The only factor that made such quick launch preparations possible was that the Gemini 6 had been thoroughly checked during more than 2 months on the pad earlier in the year. However, its launch was postponed when its target for a rendezvous in space failed to orbit, and the Gemini 6 was taken down and placed in storage. Now, it had been re-erected, and with a minimum of testing, would be ready for launch. The launch crews worked so efficiently that Gemini 6 was ready for launch in 8 days. The countdown proceeded smoothly to ignition. And then, engines shut down. A premature liftoff signal caused the automatic sequencer in the blockhouse to shut down the engines, and the flight of Gemini 6 was postponed again. However, the engine shutdown did not damage the Gemini booster or spacecraft, and the launch was rescheduled for the 11th day of the Gemini 7 flight. Astronauts Schirra and Stafford boarded Gemini 6 for the 3rd time on December 15th.
Capcom AFD voice check. Okay, work
This time, the launch was successful, and Gemini 6 began its pursuit of Gemini 7. During its 4th orbit, Gemini 6 moved alongside of Gemini 7, and the first rendezvous of manned spaceflight was accomplished. Before man can truly call himself the master of space, he must master orbital rendezvous. For this technique will be vital to the moon journey and other long-duration space missions. For centuries, man has looked to the skies and dreamed of breaking the chains which shackle him to a single planet. The space achievements of 1965 have brought him closer to his dream. Before the end of this decade, he will launch his greatest voyage. He will leave his home planet and set foot upon another world, the luminous satellite of Earth we call the Moon. His quest for knowledge will eventually take him to the vast regions of space, where he will solve many of the mysteries of our universe.